All right, this is the 7.4 extension over repeating decimals. So we've talked about different kinds of real numbers. We have rational numbers and irrational numbers. And the definition of a rational number is any number that can be written as a fraction. And we said that most numbers can be written as fractions, even decimals. Most decimals can be written as fractions. So if your decimal terminates, we just write that decimal over its place value and reduce it. If the decimal repeats, has pattern, it goes on forever, but it's got pattern to it, you can also write it as a fraction. So since repeating decimals are rational numbers, we will be able to write them as fractions, and that's what we're going to do in today's lesson. We're going to take repeating decimals and write them as fractions. To do this, a couple different things. So first of all, when the 10th digit, that's that first decimal place, when the 10th digit repeats in the decimal, write the repeating digit over as in the numerator and write it over 9. So 9 will be in the denominator. And then, of course, reduce if possible. Now, something important to note here is that if the 10th digit does not repeat, this method doesn't work. There's actually a more complicated method that we won't look at this year. For right now, you just have to know how to write most repeating decimals as fractions, which we're going to look at here. So we need to write these repeating decimals as reduced fractions. In the first example, it says 0.4 repeating. So that 10th digit is repeating. So we're going to write that repeating digit 4 over 9. 4 goes in the numerator, 9 goes in the denominator. So 0.4 repeating is 4/9. It's as easy as that. For example B, 3.6 repeating would be 3 as the whole number, and then 6 over 9, which of course that one actually can reduce to 3 2/3. So you probably remembered from all the math problems you've done this year that 2/3 is 0.6 repeating. And so 0.1 is 1/9, 0.2 is 2/9, 0.3 repeating is 3/9, which is 1/3, 0.4 repeating is 4/9, 0.5 repeating is 5/9, so on and so forth. So in example C, we've got -1, and then the 1 that's repeating as the 10th digit is going to be placed over 9, not 10. Normally, we would place it over 10 if it wasn't repeating, but it is repeating, so we're going to place it over 9. And then the most interesting of all the repeating decimals is 0.9 repeating, because this should be 9/9, and 9/9 actually reduces to 1. And so it's interesting that in math, 0.9 repeating is actually the same as 1. And it doesn't seem that that would be possible. But since this 9 goes on forever, there's literally an infinite number of them. So it gets closer and closer and closer and closer and closer to 1.0. It's actually so close that it becomes 1. It's inseparable. You can't actually tell the difference between the two numbers. So 0.9 repeating is the same as 1. All right, so now when the tenths and the hundredths digits both repeat, we write the repeating digits in the numerator and we write 99 in the denominator. So if it's got 2 repeating decimals, we put it over 99. Now this pattern continues anytime all the decimal places repeat. So if we have 3 repeating decimals, we'll put it over 999. You just use as many 9s as you have repeating decimal places. So for example E, we've got 1 and 25 over 99. Now, double check to make sure these don't reduce. An easy way to tell is to see if 3 goes in. Remember, 3 will go into any number where if you add the digits together, 3 would go into that sum. So, for example, if I want to see if 3 goes into 25, I add 2 and 5 together. Well, 2 plus 5, 7. 3 doesn't go into 7. 3 won't go into 25. So this is not going to reduce. For example, F, we've got -51 over 99. This one is going to reduce because 5 plus 1 is 6. So 3 will go into 51. It's just a matter of figuring out how many times it will. So it actually goes in 17 times. And then 3 goes into 99 33 times. So we get this reduced fraction of -17 over 33. Remember, we're reducing our fractions. In example G, we have 3 repeating decimals, so we're going to write 591 over 999. The 5 and the 1 make 6, plus 9 is 15, so 3 will go into both of these numbers. 3 goes into 591 197 times. I'm using my calculator for that. 3 will go into 999 333 times. And then I'm going to double check to see if it won't go in again. So 1 plus 9 is 10. 10 plus 7 is 17. 3 won't go into 17, so 3 won't go into 197. So we've got our reduced fraction. I didn't leave myself a whole lot of room here. I'm just going to rewrite this as negative 7 and 197 333rds. And then the last one here, we've got 1 as our whole number, and then 252 over, again, 999, because it's a repeating decimal, and there's 3 repeating decimal places. The 2 and the 5 make 7. 7 plus 2 is 9. 3 will go into here, so we can reduce again. 3 goes into 252 84 times. So this is 1 and 84 over, and then 333. And then 84 is divisible by 3 because 8 plus 4 is 12. So we can reduce this again to 1, and then 3 goes into 84 28 times, and 3 will go into 333 111 times. So sometimes we have to spend a little extra effort reducing our fractions. Of course, if 3 could have gone in twice, I could have just taken 9 out of both of these numbers. That would have saved me a little bit of time, but I didn't see that 9 went in right away. So that's totally fine if you just reduce by 3 twice. And that's it. That's how to write most repeating decimals as fractions. The only kind of decimal we haven't talked about is the kind of decimal where you would do 0.26 and just the 6 repeats. So that's a little bit more tricky to write, and we're not going to worry about those this year. That's something you can look at later on.